Logarithms. You know, that one topic in math class that just feels kind of weird? It's a huge stumbling block for so many people, but honestly, it really doesn't have to be.
I mean, have you ever been there, staring at a problem? Maybe it's the night before a big test, and you just get that sinking feeling of confusion?
And you're just thinking, okay, what does log even mean?
Well, if that sounds familiar, you're in exactly the right place. Because in the next few minutes, we're going to give you the master key that unlocks this whole thing. And on top of that, a toolbox with just 3 simple rules you need to solve these equations with, yes, total confidence.
Okay, so let's start with that master key. Seriously, this is the single most important idea. Once you get this, I promise everything else just clicks. So, the big question, what is a logarithm? The answer? It's surprisingly simple. A logarithm is just an exponent. That's it. That's the secret. This relationship right here, this is your master key. Saying log base b of y equals x is just a fancy way of saying b to the power of x equals y. They're two sides of the same coin. I like to think of it as a little conversion dance. You can always go back and forth. So, we all know 3 to the power of 4 is 81, right? The log way of saying that is just asking a question. Hey, what power do I need to put on 3 to get 81? Well, the answer is 4. So, log base 3 of 81 equals 4. See? Same idea, just different dance moves.
All right, let's actually use this master key to unlock a problem. You're about to see just how powerful this one little idea is.
So say you see this. Log base 2 of 16 equals x. No sweat, we just use our key. Let's rewrite it. It's asking 2 to what power gives me 16? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. That's 2 to the power of 4. So x has to be 4. Easy, right?
Okay, you've got the master key. Now it's time to build out your toolbox. And the good news is, you only need 3 main tools to handle pretty much any problem they can throw at you.
Tool number 1, the product rule. This one's all about what to do with multiplication.
So here's the deal. If you're adding 2 logs together, you can combine them into a single log by multiplying their insides. Why does this work? Well, remember what a log is? It's an exponent. And what do you do with exponents when you multiply numbers with the same base? You add them, so it makes perfect sense. And remember, this works both ways. You can condense 2 logs into 1 or expand 1 into 2.
Next up, tool number 2 is the quotient rule. And if you guessed it's basically the opposite of the product rule, you'd be absolutely right. This one's for division.
So if addition meant multiplication, it makes sense that subtraction means division. When you subtract 2 logs, you can combine them into 1 by dividing the insides. And again, this goes right back to your basic exponent rules. When you divide powers, you subtract the exponents. And just like before, you can go in either direction with this one.
All right, last tool for the toolbox, number 3 is the power rule. This one is super handy for when you've got an exponent inside of the logarithm.
Now this one feels a little bit like a magic trick. That little exponent up there, you can literally just grab it and move it down to the front to become a multiplier. And it works the other way too. A number multiplying the log can hop back up to become an exponent. This is a game changer for cleaning up messy equations.
Okay, master key? Check. Toolbox? Full. Let's head into the workshop and actually get our hands dirty. First, let's just use the master key on its own on a pretty standard-looking problem. Okay, so you see this. Log base 3 of the quantity 5x plus 1 all equals 4. Don't let it intimidate you. Just pull out that master key. Let's rewrite it. It becomes 3 to the power of 4 equals 5x plus 1. Well, 3 to the 4th is just 81. And look at that. All of a sudden, it's just a basic algebra problem. Subtract 1 from both sides, that's 80. Divide by 5, and bam, x equals 16.
But hang on, before we get too far, I need to give you one crucial piece of information, a fundamental rule. You can only take the log of a positive number. You can't take the log of 0, and you definitely can't take the log of a negative number. It just doesn't work. Now, just tuck that little fact away. It's going to be really important in a minute.
All right, time for the main event. Let's look at a problem where you're going to need everything we've talked about, your tools and the master key.
So what happens when you get something messy like this? We've got 2 different logs on one side. We can't use our master key yet because it's not a single log. So, are we just stuck?
No way. This is exactly why we have a toolbox. We just need to tidy things up a bit first. Okay, we're adding two logs, so which tool do we need? The product rule. We can combine them into one single log by multiplying the insides. So that's x times the quantity x plus 4. Now we've got a single log, and now we can use our master key. Let's rewrite it. 2 to the power of 5 equals x squared plus 4x. From here, it's just algebra. That becomes a quadratic equation, and when you solve it, you get two possible answers, x equals 4 and x equals -8.
But hold on a second. I said possible answers. Are they both legit? This brings us to the single most important final step. You gotta watch out for fake solutions.
So, let's look at what we've got. We have x equals 4 and x equals -8. Are they both real answers to our original problem?
Remember that warning I gave you a minute ago? This is where it comes back to bite you. You have to check your answers by plugging them back into the very first equation you started with. We're hunting for what mathematicians call extraneous solutions.
Okay, let's check them. First, let's try x equals 4. If we plug that in, we get log base 2 of 4. That's fine. And log base 2 of 4 plus 4, which is 8, also fine. So x equals 4 looks good. Now let's try x equals -8. The very first term becomes log base 2 of -8. Whoa, red flag. Remember, you can't take the log of a negative number. That means -8 isn't a real solution. It's a fake.
So, once we throw out that fake solution, we're left with just one real answer to that whole messy problem. X equals 4.
So listen, if there's one thing you take away from this last part, it's this. When you solve for x, you're not finished. You always have to go back and check your answers in the original equation. It's the one step everyone forgets, and it's what separates getting the question right from getting it wrong.
And that's pretty much the whole game. You've got the master key to know what a logarithm really is, you've got the 3 tools you need to take equations apart and put them back together, and you know about the all-important final check to make sure your answers are real. So the only question left is, now that you've got all this, what other math puzzles are you ready to go unlock?